Hey, good people. Arthur Moore is here. I hope all is well. In this video, we're going to look at the antiderivative. So we're going backwards from the derivative and we're looking at the antiderivative and indefinite integration. So it says to find a function, capital F, whose derivative is f of x, and for this capital F, that's the antiderivative, is f of x equals 3x squared. You might use your knowledge of derivatives to conclude that the antiderivative is equal to x to the third. So remember, when we found the derivative of a function, we subtracted one, we multiplied by the exponent, and then we subtracted one from the exponent. So it's saying basically that to find the antiderivative, then you would need to, so let's write that down. So when we found that our derivative, we multiplied by the exponent, and then we subtracted. So the antiderivative would go in just the opposite direction. We would add 1 back to the exponent and then we would divide. So it's just going back the opposite way. And that's the basics of the antiderivative. Excuse me for the power rule. So you're just going back opposite. So the function f is an antiderivative of f. Note that f is called an antiderivative of f rather than the antiderivative of f. So there's a and versus the, because if you remember, you could have different constants at the end of this and still have the same function. So the antiderivative of 3x squared could be x to the third. It could be x to the third minus 5. It could be x to the third plus 97. Why is that? Well, let's look at it. If we found the derivative of x to the third, so if we found the derivative of that, that would be 3x squared, correct? If we found the derivative of this one, x to the third minus 5, first derivative, that would still be 3x squared because remember the derivative of a constant is 0. If we found the derivative of this last one out here, that would still be 3x squared because the derivative of a constant is 0. Therefore, in fact, any constant c, for any constant c, the function of capital F of x equals x to the third plus c. So this plus c, we call it a constant of integration. So when we integrate, and this little symbol here means to find the derivative or integrate, the antiderivative or integrate, antiderivative of f of x d of x is equal to capital F of x plus the constant of integration. So this is the integrand symbol. This is the variable that we're integrating with respect to, and the capital F, we're letting that represent the antiderivative. And that C is constant of integration. So for the indefinite integrals, we'll use this capital C. For the definite integrals, we'll actually do some calculations and we won't need the C. Okay, so you may want to write that down. You will see that little symbol a lot to find the antiderivative or saying we're integrating that function. All right, so some basic integration rules. We have a lot of them here. You can find these in your textbook. You can also find them online, but one of the basics is the derivative of a constant is equal to 0. Derivative of k to the x is equal to k, and so on. If we have a multiplier, then we find, well, that's differentiation. I'm sorry. We're looking at integration. The integration of 0 is a constant. We use c. So it's just the opposite here. The integration of k dx is kx plus c. So that's where we add the 1 and then we divide by 1. The integral of k f of x dx, we pull the constant out, constant multiple out here, and we integrate the f of x, and then we multiply the k by whatever we get after we integrate. The integrative functions being added or subtracted, we integrate each function separately and then add the results. Our basic power rule says the integration of x to the nth d of x is just the opposite of finding our derivative. In this case, we add 1 to the exponent and then we divide by that new exponent, adding the constant, the constant of integration there. Integration of cosine of x is sine of x. Integration of sine of x is negative cosine of x. And you can look at the other ones down here as well. Alrighty, let's look at a few problems here. So we want to find the indefinite integral here of these problems. So the indefinite integral of x plus 7. And you can look at these separately. And this is not an S, it's the integrand symbol, sorry. It's 7 dx. Okay, so the integral of x dx, you add 1 to the exponent. We already have 1, so we add 1 more to the exponent. That becomes x squared, and then you divide by that new exponent. Same for 7 dx. You don't see an x here, so you add an x in there, x to the first, and then you divide by the new exponent, which would be 1. And then you add your constant of integration. So we have 1/2 x squared plus 7x plus c. And you can check this by finding your derivative of what you have here. So if we wanted to find the derivative or find the first derivative of this, we would say 2 times 1/2, then subtract 1. So 2 times 1/2 is x to the first power, plus 1 times 7, because that's the exponent, subtract 1, so the x will go away, and the derivative of any constant is 0. So we end up with x plus 7 right back where we started, dx. So that was a quick check. So to find your antiderivative, add and divide, add and divide. So we look at each one of these separately, each one of these terms separately in number 14. Add 1 to the 3, which gives us 4. So we have 8x to the 4th, and we divide by that new exponent. Same thing here, and we'll call this capital F of x. Add 1 to the exponent, and then divide by the new exponent. And then for 4, just be 4x, and we divide them by that 1, and then add in your constant of integration. And then simplify. So we have 2x to the 4th minus 3x to the 3rd plus 4x plus c. All right. Number 21. We have x plus 6 over the square root of x. So again, we probably want to go ahead and rewrite this radical in exponential notation. And let's go ahead and separate these into separate fractions as well. So x over x to the 1/2 plus 6 over x to the 1/2 dx. Okay. And then let's move our denominators up. So on this first one, we can use our quotient rule for exponents where we subtract the exponent. So 1 minus 1/2 is 1/2. And then plus 6 times x to the negative 1/2. And then you integrate each one of those separately. So the integration of x to the 1/2. Remember, we're going to add 1 and then divide by the new exponent. So if I add 1, that's the same thing as adding 2 over 2. And then if I divide by the new exponent, so that's x to the 3/2 divided by 3/2. So add 1 here. That's the same thing again as adding 2 over 2. So 6x to the 1/2 divided by 1/2 plus the constant coefficient, constant of integration. And then simplify this a little bit. So if we divide by 3/2, then we're multiplying by 2/3, x to the 3/2. And then here, if we divide by 1/2, then we're multiplying by 2. 6 times 2 is 12, x to the 1/2 plus c. And then you can write that back in radical form, or you can leave it, should be able to leave it in exponential notation. All right, all right, all right. Let's move right along. Number 25, we have the integral of 5 cosine of x plus 4 times sine of x dx. Again, you're going to integrate each one of those separately. So let's rewrite this. And these constants, these multipliers, they can come outside of the radical. So not the radical, but the integram. So 5 times the integral of cosine of x dx plus 4 times the integral of sine of x dx. So you can rewrite it like that to show what you're doing. The integral of cosine is sine. The integral of sine is negative cosine. So we just have 5 times sine of x plus 4 times negative cosine of x. So that gives us 5 times sine of x minus 4 times cosine of x. And that's it. So not very difficult. Just a little bit different, just going in the opposite direction of the derivatives. Okay. Alrighty, let's look at number 27. We want to find the integral of 1 minus cosecant t times cotangent t dt. And if you go back and look at your integration rules, then the derivative of, or the antiderivative of cosecant t cotangent t dt would be negative cosecant t. So we have the integral of 1 dt, and since that's just a regular number, we'll just say 1 times the integral of dt minus the integral of cosecant t cotangent t dt. So the integral of dt is just t, and then 1 times t is t. So the integral of cosecant t cotangent t is negative cosecant t. And then just clean that minus negative up and you're done. Okay. So when you take this antiderivative, you can use this to go back to a position or find your position function. So solving a vertical motion problem, we have a ball is thrown upward with an initial velocity. So remember that initial velocity will be your first derivative there of 64 feet per second from an initial height of 80 feet. Let t equal 0 represent the initial time. The given conditions can be written as follows. So we have here that at 0 seconds, the height is equal to 80. And then the first derivative of 0 gives us the velocity or the speed, which is 64. Now, based on what's also known and given, it's the acceleration due to gravity. And you can look this up, but your acceleration due to gravity, and remember acceleration will be your second derivative. So your acceleration due to gravity is equal to negative 32 feet per second. So your second derivative is negative 32 feet per second. So the question asks you to find the position function given the height s as a function of time t, and then when does the ball hit the ground. So to find the position function, we need to get back to S of t. S of t is what we're trying to get back to. So we know that the s double prime of t is equal to negative 32. So if we find our first derivative, and that's what's happening here below, if we integrate the first derivative or integrate the second derivative of t dt, that puts us back at the first derivative. And then from there, if we integrate the first derivative of velocity, that puts us back to the position function. So we have to work our way back up. So if we integrate s double prime of t, which is equal to negative 32, that's going to put us back at s prime of t, and the integration of negative 32 dt. Remember, you're just integrating the dt and keeping the negative 32, so that integration is equal to negative 32t plus the constant of integration, and we'll call it 1 because we may have more than one constant of integration. So that's how we got to this next line here. But we know something about s prime of t from our given up here where it says s prime of 0 equals 64. So that means if we replace t with 0, then the position, or that s prime of 0, equals 64. So since s prime of 0 equals 64, I can actually find the c that goes with this by saying 64 equals negative 32, replacing t with 0 plus c1. Therefore, 64 equals c1, c sub 1. And since 64 equals c sub 1, what that gives me is s prime of t, in this case, equals negative 32t plus 64. So that gives me my first derivative of s prime of t. Now, if I want to integrate this, and it's negative 32t plus 64 dt. So now when I integrate this will move me back up to just s of t. So look down here at this line here. It says s of t is equal to the integral of s prime of t dt. So if we integrate negative 32t plus 64 dt, then remember, to integrate, we add 1 to the exponent and then we divide. So we add 1, we already have 1 here, we add 1 to that exponent, that gives us 2, and then we divide by 2, that gives us negative 16 t to the second. And then 64, we need to just add the variable in there, so that gives us 64t plus the c sub 2, constant of integration. Now again, we know something about s of t from our given information. It says when when the time is 0, then the position is 80. S of 0 equals 80. So again, we can find this c sub 2 and have a definite number there and continue to work to find our position function. So using that initial height, s of 0 equals 80, we let 80 equal negative 16 times, replace the t's with 0 because we have s of 0, 0 squared plus 64 times 0, and c sub 2 equals 80. So now we can take that 80, plug it back in here, and we will have our position function. S of t equals negative 16t squared plus 64t plus 80. So that's part A, that's the position function. Part B asks us to find, or ask, when does the ball hit the ground? When does the ball hit the ground, or when is the height equal to 0? So to do that, we will replace s of t with 0, and we would solve this equation. Now the first thing I see that I can do is to divide everything by negative 16, both sides by negative 16. So I'm going to flip this around. That gives us t squared minus 4t minus 5 equals 0. And then I can factor. I need factors of -5 that equal 4. So that would be -5 and +1. And then set those factors equal to 0 and solve. So t equals 5 and t equals -1. And we know we're looking at time, and time has to be positive. So when at 5 seconds, that after 5 seconds, that's when the ball hits the ground, and you can see that on the graph. So that's the vertical motion problem, where you're throwing a ball up and dropping it. You find out the position function, and then you can use the position function to find where the ball is at any given time. Alrighty. So let's look at one more problem here, and it says find a particular solution. So we're using the same process that we just used on that last problem to find the particular solution that satisfies the differential equation and the initial condition. All right, so we just want to work our way backwards. We have f second derivative of f double prime of x equals 2, or the second derivative equals 2, the first derivative of 2 equals 5, and f of 2 equals 10. So our first goal is going to be to find f, and our final goal is to find f of x. That's our final goal, is to find f of x. So the first thing we need to do is find f prime of x. And we know that f prime of x is equal to the antiderivative of f double prime of x dx. So we will, since knowing that f double prime of x is equal to 2, then we know that f prime of x is equal to the antiderivative of 2 dx. So f double prime of x is equal to 2x plus c. And then we can find out the value of c. Sorry, that should be f prime of x. We can find the value of c by using the information that says that f prime of 2 equals 5. So that means that f prime of 2 equals 5. So therefore, f prime of 2 equals 5. Therefore, 5 equals 2 times 2 plus c sub 1. That's 4. Subtract 4 from 5, and c sub 1 equals 1, which gives us f prime of x equals 2x plus 1 in this situation. All right, so now we're going to take that information, because we know that f of x, which is what we're trying to find, is equal to the integral of f prime of x dx. Okay. All right, so let's integrate f prime of x and see what we come up with. So we know that f of x is going to be equal to the integral of 2x plus 1 dx. So f of x will be equal to the integral of 2x, add 1 to the exponent, divide by the new exponent. The integral of this constant 1 is going to be 1x, and then plus your constant of integration. And we'll use c sub 2 since this is the second one we're looking at in this problem. So we have f of x equals x squared plus x plus c sub 2. Now again, we know something about f of x when x is equal to 2. F of 2 equals 10. So since f of 2 equals 10, then when f of x is equal to 2, then x is 10. And we can find our c sub 2 in this particular situation. Oh, sorry about that. I did that backwards. Let's rewrite that. X is equal to 2 and f of x is equal to 10 there. All right, so you have 2 squared plus 2, so 4 plus 2 is 6. Subtract 6 from 10 and you get 4. So c sub 2 equals 4. And we take that c sub 2, plug it back in for c sub 2 in that function. That tells us that f of x equals x squared plus x plus 4 with that given information. So it's just like the previous problem. We just didn't have all the words in the application to go with it. So that's the basics of integration and the antiderivative. I hope you found this video to be helpful, and I will see you on the next one. Thank you.